So I want to do a few things. So first, um, sketch a graph of this function. Sketch a graph of y equals f of x on the interval, let's say -1 to 1. Part B, show that f is continuous for all x. And then part C, calculate the integral of f from -1 to 1. So I'm actually going to give you a few minutes to work on this yourself, right? So some of this, so first of all, part A is something you should be able to do, say from pre-calculus, just your knowledge of graphs of exponential functions and polynomials. Part B is something we did at the very beginning of the course, like the second week of classes. And then part C is just a mini review of some stuff we did last week with fun with the theorem of calculus. Okay, so I'm going to give you a few minutes for that. Let's say 6.5 minutes. Try to get as much of this done as possible. Right. So let's go through each part. Okay, so I can't really ask you too much about part A, but the idea following. Okay, so we know that at 0, both of these pieces are actually equal to 1, right? E to the 0 and 1 minus 0. Now e to the x, so let's mark -1 to 1 on the x-axis. Now e to the x, we know what the graph of that looks like, right? Just looks like that. It actually has to pass through this point here, 0, 1. So it's something like that. And then y equals 1 minus x squared. So this has roots at -1 and 1, and it passes through that point on the x-axis. So it looks like this, but we only want the right piece of it. So something like that. Right. Now, part B asks us, show that this function is continuous. So can someone remind us, how would I show that this function is continuous? And I'm warning you, the answer is not look at the graph. Right? Graphs are not proofs of continuity. All right, so Brennan says limits. Matan says take left and right limits. Okay, good. So, um, so it technically said for all x, let's actually just take care of the all x except 0 first. So the functions e to the x, say y equals e to the x, and y equals 1 minus x squared are continuous for all x. So we need only check continuity at 0. Right? X equals 0 is where these two pieces kind of switch over from one another. So we only need to check continuity there. Okay, so for that, as we said, we need to compute the left limit. We need to compute the right limit. Isn't there something else we have to compute? Because this would essentially just give us what is the limit as x approaches 0, right? Together, the left and right limit tells us the overall limit. Let's see. So Hannah f of 0, Brennan overall, Hannah f of x overall. Okay, so I see so there are some incorrect answers here. So the overall limit, notice that the overall limit is actually determined by the left and right limits. So when we compute the left and right limits, we are computing the overall limit, right? If these two numbers happen to be the same, then that is the overall limit. If those two numbers have to be different, the overall limit doesn't exist. But that's not what we need for continuity, right? The overall limit, I mean, we do know the overall limit, but we're already getting that anyway from the left and right limit. So the other third thing that we need is actually f of 0, which some other students actually said. Good. So I actually do see that that is a common mistake. A lot of students put x going to 0 from the left, x going to 0 from the right, and then limit as x approaches 0 without left or right. But that's incorrect, right? This third thing actually comes from the first two. Right? This thing down here, this is not the same thing as f of 0. Not I mean, in this case it is, but not necessarily, right? Not in general. So the thing we're looking for actually is f of 0. Okay, so for the left limit, I need to use the left piece, which is e to the x. I get e to the 0, which is 1. For the right piece, I need to use 1 minus x squared. So I get 1 minus 0. I get 1. And then for f of 0, where was the equal sign? The equal sign was actually on the 1 minus x squared. So all three of these numbers are equal, so therefore the function is continuous. Okay, now let's look at part C. So I want to find the integral of -1 to 1 of this function. What general strategy did you use to compute this integral? Let's see. So Samir said integral of e to the x from -1 to 0. Sana said split the integral. And Samir said plus the integral of 1 minus x squared. Okay, good. So all of these are the correct answer, right? So what Sahana said split integral, right? You want to split this up into two pieces. So what's really happening is, keep in mind that the integral from -1 to 1, I'm really being asked to find the area of this entire shaded region. Now I can break that up into two separate regions. I can say that this is the area of the left region plus the area of the right region. Right. Why do I want to do that? Well, because I want to compute these integrals using fundamental theorem of calculus, but the function actually has kind of a different formula on each of these intervals. So I definitely do need to split this up. So I'm going to say that this is the integral from -1 to 0 plus the integral from 0 to 1. So in other words, I have this blue integral that's from 0 to 1, and I have this green integral, -1 to 0. So really this problem is, the integral is really too many problems. I have too many integrals. So let's do each of those. So on the interval from -1 to 0, f of x, let me keep writing the dx. A lot of times in high math we don't put the dx because it's understood, but I think it's important for you guys to actually keep writing it. Okay, so on the interval from -1 to 0, f of x is the same thing as e to the x. Okay, good. So I'm just replacing f of x with e to the x there. And then on the interval from 0 to 1, f of x is the same thing as 1 minus x squared. So now we have two little mini integrals. So I do each of them by doing the fundamental theorem of calculus, right? The antiderivative of e to the x is e to the x, and I substitute in -1 and 0. That's one integral. And the second integral, I find my antiderivative. I get x minus 1/3 x squared, and I x cubed, sorry. And then I substitute in 0 and 1. Okay. Now, make sure you actually do the parentheses, right? I mean, even though this is a plus, just make sure this is one number minus another number, and then plus one number minus another number. So just to make it kind of clear what's going on, right? All the colors correspond to each other, right? I'm just computing each integral separately from the other. Okay, so plugging in 0 here, I get e to the 0, so that's 1. Then e to the -1, so I write that as 1 over e. And then over here, plugging in 1, I get 1 minus a third, so that's 2/3. And then 0 gives me 0. And then doing all this arithmetic, I finally come up with that we get 5 over 3 minus 1 over e, and that is the final answer. All right, any questions about that? All right. So one thing I do want to point out, sometimes I see this mistake with these piecewise functions. You do not, for instance, find the antiderivative of each one separately, right? You do not go, okay, e to the x, um, x minus 1/3 x cubed, and then substitute 1 into this into the second piece and -1 into the other piece, right? You're not doing one number into each piece, but you're actually doing two separate integrals, right? So each piece actually gets two numbers from -1 to 0 and then 0 to 1, right? So that's the big mistake I see with piecewise functions.